The next, the second of the four topics in Chapter 15 is sequencing various jobs through one station. It's called single station scheduling. All right, so I want you to focus on only 3 rules. The first one is first come, first serve, which it means that we're going to sequence the jobs alphabetically through the station. The second sequencing rule is the shortest processing time, so we're going to sequence the shortest jobs first. And then early due date would mean we're going to sequence the earliest due jobs first. So we're going to evaluate these various sequencing rules looking at average flow time, average late time, and average number of jobs in the system. So I'm going to do a quick little example on how to use these various sequencing rules. So let's say in the problem we're given the following. We're given 6 jobs, A through F. Each job has its own processing time, and that's how long it takes to either assemble or complete it on the machine. And then the due date is shown in days from now. All right, so it'll take us, I guess these are in days, it'll take us 2 days to complete job A, and it's due 7 days from now. All right, so if we did the first come, first serve sequence, what we're going to do is just keep these jobs in alphabetical order. Now you will notice I've added 2 columns. The first is the flow column. And so this is just, what are the end times of each job if we do them in that sequence. So for instance, job A, if we start at time 0 and complete it, it's going to take from time 0 to time 2. Then we would do job B, we would start at time 3, and it's again takes 8, so it's going to be done at job 10 or time 10. We're going to start C at time 11. It's going to be done 4 days later, or time 14, etc., etc. Now the longest time, or the time to get all jobs through the station, is called the make span time, and that's going to be 41 days. And then the 120 below that is just the sum of all the flow times. So the average flow is just the sum of the flow divided by the number of jobs. It's 20 days. And then the average number of jobs, it's kind of a congestion measure, is just the total flow divided by the make span, which is 3 jobs, okay? So any questions on how to calculate that flow column? So the late column is what you're doing is you're comparing the flow to the due date. So if the flow is less than the due date, then the job is not late. So for job A, you can see that the flow is 2, the due date is 7, so it is not late. For job B, it'll be done at time 10. It's not due till 16, so it is not late. Job C, on the other hand, it won't be done until 14. It was due at time 4, so it is 10 days late. And then job E will be done at 24. It was due at 17, so it'll be 17 days late, et cetera, et cetera. So that's how you calculate the late times. And so if you add up the total late, it's 54. So then the average late is 54 divided by 6 jobs, or 9 days late. So your goal here is to minimize these metrics. So is first come, first serve the best sequencing rule? Well, we don't know. We have to compare it to other sequencing rules to see if these are the lowest we can get. All right? So we'll try shortest processing time and early due date next, but are there any questions on this example so far? Okay, so this shortest processing time, again, you notice what I've done here is I've changed the order of the jobs, and I've started at the lowest time, and then the last job is the longest time, all right? So I've changed the sequence of these jobs. And again, the flow and the late are going to be calculated just like they were in the first example. I can calculate then my average flow, average late, average number of jobs, all right? And then with the early due date, again, what you can see is I have changed the sequence again. And what I've done is I've sequenced the earliest due date first. So job C is due in 4 days, job F, 18 days. So again, I've sequenced them with the shortest or the earliest one first. And again, I calculate my flow and late, just like I did with the other two examples, and then I can calculate my metrics. So if you compare the metrics now, you can see that the earliest due date is tied for the lowest average flow. It does have the lowest average late, and it's tied for the average number of jobs. So it is the best rule. It does the best job at minimizing those three metrics. So that would be how you can select the sequencing rule that's going to optimize your efficiency. All right, and that's basically all there is to single station sequencing. Any questions on this example?